Good afternoon. My name is Sarah Rongione. Today I'll be presenting a case study on behalf of the Johns Hopkins Immunogenetics Laboratory entitled DDA, Donor-Derived Antibody. I'd like to thank the ASHI Program Committee and abstract reviewers for the opportunity to present this today. The patient is a 47-year-old Caucasian female lung transplant recipient with a history of cystic fibrosis. The reported sensitization history included no previous transplants, known transfusions, nor pregnancies. The patient had a very low-level third-party antibody to DQA2 and no DSA prior to transplant. Anti-HLA IgG antibody was characterized using Luminex bead-based phenotype and single antigen panels from 2 independent manufacturers. The patient received a bilateral lung transplant on October 3rd, 2013 from an ABO-identical blood group B, 59-year-old male deceased donor at Johns Hopkins Hospital. Shown are the HLA types of the lung recipient and donor. As you can see, there are 10 mismatched antigens covering all the loci tested. They are highlighted in red. Tests of the patient's pre-transplant serum from day 0 showed specificity for DQA2 antibody, which was not donor-specific. On post-transplant day +4, antibody specificity testing identified an increase in third-party antibody to include A30, A31 class 1 antibody, as well as DQB2 class 2 antibody, in addition to the DQA2 present on day 0. Because this specificity was not related to any donor mismatches, we wondered how this arose, or if it had been a sample switch. A new specimen was requested to confirm reactivity observed on day +4. On day +7, the presence of third-party antibody to the A30, A31, and DQB2 was corroborated. We also saw antibody to the donor's DQB7. Given the patient's sensitization history, we did not see any obvious reason why the patient would be making this third-party antibody. Knowing that in lung transplant, a fair amount of immunocompetent tissue is transferred along with the allograft, we wondered if the antibody could have originated in the donor. Routinely storing donor serum, we were able to test this for HLA-specific antibody. Here we show the results of antibody tests of the donor and recipient sera. As you can see, the patterns are identical, but the strength of the reactivity in the donor serum is much higher than that in the patient's serum. Here the results are expanded so you can see the donor's MFI values range from about 14,000 to 22,000 MFI. The recipient serum showed MFI values roughly from 1,000 to 5,100. The pattern and specificity is the same. In an effort to further understand this patient's antibody testing results, the previous medical history of the deceased donor was investigated. Thorough documentation by the OPO showed the deceased donor's medical summary noted that he had been the recipient of a kidney transplant in 2010. Shown here is the HLA typing of the lung donor. On the bottom panel is the HLA typing of the deceased donor's previous kidney transplant obtained from UNET. Here you see that the lung donor had been mismatched for A30 and DQB2 shown in red, and this would explain the presence of those antibodies in the serum of the lung donor. We believe this suggested the source of this antibody in the lung recipient was donor immunocompetent tissue transplanted along with the lung. Previous reports have shown transplantation of donor immunocompetent tissue can have serious consequences, such as catastrophic GVHD and severe hemolysis, indicating recipient-directed humoral and cellular responses. This graph shows the course of DSA and third-party antibody over time. Immediately post-transplant, third-party antibody to A30 and DQB2 rose to a higher level than DSA to DQ7. Tests of sera obtained monthly from the lung recipient have shown a steady reduction in antibody strength and breadth. We conjecture that the decline in third-party specific antibody is due to both treatment and destruction of third-party specific B cells by the DSA. Please note that these values are from phenotype panels, and the corresponding SAB data yielded much higher MFI values. You aren't likely to have many donors that are previous transplant recipients, but the donor could be a multiparous female sensitized through pregnancy. This indicates the need for access to the donor's medical history. This case illustrates the value of post-transplant monitoring that may provide signs of early indications of GVHD. I would really like to thank ASHI, the meeting organizers, for the opportunity to speak to you all today, and I'd like to acknowledge the hardworking team from my lab at Johns Hopkins.
Yeah, after this, open for questions.
So, did you check for chimerism from the donor in this patient? The reason I'm asking is that Adriana Zini, not many years ago, showed that if a patient does have some donor cells, if there's chimerism in there, they actually do much better. So I thought, if you looked for the chimerism, STR analysis.
No. No. Chimerism testing isn't done in our lab. But, yeah. No, we didn't. But we'll send it to you. I'll send it to you Monday.
The recipient give me the work hire.
So how long is the follow-up of this patient? For how long have you been testing this antibody?
I think our last sample was in July. July. And I checked right before I left and we hadn't had another sample. I think we're quarterly on this patient now. So it's really whenever they feel like drawing a sample.
So do you feel that these donor cells are disappearing?
Yeah, I think it'll continue to keep decreasing until it's gone, hopefully.
So I assume that, as you mentioned in the beginning of your talk, that there's a lot of lymphatic tissue associated with the lung, and that tissue could have been transplanted along with the lung. But, this is an unusual situation because in kidney transplants, we usually don't transplant lymphatic tissue, so I would assume you would agree that this is not a problem for kidney transplants.
Right, and I think the literature that I was referencing, I think we only saw it in liver and lung because of the nature of the transplant and what goes along with the organ.
The next